bit of revision. All the way back to set notations and language. The reason why functions of chapter 1 most students find difficult, it's not the maths, it's the language. You look at it, you see a lot of different symbols, and you're like, oh my god, I have no idea what it's saying. Don't be afraid. All the alphas and betas and whatnot, it's just a letter. You just need to be able to read it. Okay, so I'm going to teach you how to read them. We're going to get used to these terminologies and what they each mean. Now, sets of numbers. Okay, so when it comes to mathematics, we have the null symbol, okay? Because if you don't put the slash through it, it looks like a 0. You think it's an actual number. So doing a slash through it means null, means empty, okay? R, which means what again? Real numbers. What is real numbers though? What is real numbers? Real numbers, all numbers, very good. Any number that you can think of, fraction, decimal, rational, irrational, those are real numbers. That's on the number system, unless you're doing specialists, there are imaginary numbers, right? We're working with real numbers, meaning that we only know it's decimal, non-decimal, fraction, surds, but there's no such thing as square root of -1, for example. Square root of a negative number is undefined. We can't do that, but you can do it in spec because it's imaginary, yeah? So we only deal with real numbers. R means every number you can think of, right? Then you got Q. Anyone know what Q is? What's Q? Rational, very good. Rational numbers. The question is, what is a rational number? We use it quite often. When you learnt it pretty much all of from 8 all the way down, and it's 9 and 10 that you started learning irrational numbers. So, question is, what is rational? Because it will be important when the questions ask you to prove or show that these are rational numbers or irrational. You need to know what that means. So, what is rational? What is rational number? Someone explain it to me. I want to randomly pick someone from the roll, actually. Let's go with Cindy Huynh. What is a rational number? They are parts of real numbers, it's true. Give me an example that you think is irrational, and give me an example of what you think is irrational. 3 is irrational, true. What might be irrational? Exactly. That's it. The definition that in the simplest form that I can give you, a rational number is a number that is finite, okay? A rational number is a number that you can write down, okay? So 1/2, 3, 0.1, those are rational numbers. What are irrational numbers? Numbers that you can't write down. So square root of 5, you type in your calculator right now, or square root of 3, it'll go on infinitely. Pi is an irrational number. Pi will be like 3.1452 and it goes on infinitely, right? It's not a number that you want to write down. A number that you can write down is rational. I know that's the most simplest way I'm going to describe it to you. But the question is, what about 0.33333333333 onwards? Is that rational or irrational? Why rational? Because you can express that as 1/3. So 1/3 can be written down. So 1/3, any recurring decimal, say, any recurring decimal, 1/3, yes, we can write that one down, but technically this is an 0.33, but because it's predictable, that's rational numbers. Irrational numbers are numbers that you can't write down. You can't express it. You can't express it in a very concise way. So, right here, what I wrote here is A and B, where A and B are integers. Anyone remember what integers mean back in year 7? What's an integer? A whole number? What else does it have to be? Positive and? Positive and? Negative. Okay, so if a number is whole numbers and it's positive and a negative number, then it is an integer. So what is this really trying to say? It says, how do you know if something's irrational? By definition, if you can change it into a fraction where the numerator is a whole number, that is positive or negative, doesn't matter, it's a whole number, and the denominator is a positive and a whole number or negative number, doesn't matter. As long as these two are integers, and you can express it as a fraction, that is a rational number. That's why you can't do it for pi. But if you estimate pi, then it's 22 and 7. Then you make it a rational. But technically, it's not. It's an estimate, right? 1/3 is exactly 0.33333. Okay, that's why this is a rational number. See, that's an integer. That's an integer. 1's an integer, 3's an integer. That's a ratio or a fraction, and hence this is called a rational number. Why is 2 a rational number? Because 2 can be written as 2/1. 2 is an integer. 1 is an integer. That's why whole numbers like 2 is a rational number. 1/3 is a rational number. Why is 0.5 a rational number? Because you can write that as 5 out of 10. or 1 out of 2. Does that make sense? Okay? But in the scheme of things, if you really didn't understand that, I still prefer that you did. But if you didn't, Q, just remember it's rational. It's numbers that you can write down. Irrational means you can't write it down. So root 2, pi, mostly square roots really, surds, any square roots. And that's what you learned in year 10. You learned how to work with irrational numbers. Rationalizing denominators, if you remember back in year 10, rationalizing denominators. The aim is to make an irrational number rational. So for example, root 3, that's irrational number. How do you make it a rational number again? What do you do? Yeah, times by itself. Because remember when we had 1 over root 3 and they said rationalize the denominator, rationalize means make it a rational number. The denominator is root 3. The only way to do that is if you times it by itself. Root 3 times root 3, and root 3 on the top, you get root 3 over root 9. But then root 9, we know it equals to 3. That's why we can say that's rationalized. That's a rationalized denominator, and that's what rational numbers are. Okay? But anyways, so now we know Q represents rational numbers. What does Z mean again?
Irrational.
No, not irrational. It's a good guess, that. I would have thought that's it. Anyone know? What's Z? Integers. Z stands for integers. Integers, which we already know, it's a positive or negative whole numbers. And then what do you think N stands for? What does N stand for? Can I have Daniel? Natural numbers. What does natural numbers mean? Very good. It's numbers that we can naturally count. Think about it in primary. If you're thinking about the year levels, it's actually done in year levels and how you learnt it. In primary school, you only ever learnt natural numbers. You first learnt how to count. 0, 1, 2, 3, 4, 5. They're all whole numbers and they're all positive numbers. Okay? I mean, yeah, they're all positive numbers and they're all whole numbers. So you first learnt natural numbers. They call it natural because you can count it naturally, right? Then you went to year 7. So between, primary school all the way up to year 7, you learnt integers. Not only did you know positive, now you had to learn negative numbers. So we call them integers. So that's your next stream, right? Then on top of that, once you have all the positive numbers and all the negative numbers, they're all whole numbers though, but there had to be numbers in between. That's where rational numbers come in. So you had numbers. So if I draw a diagram for you to see, you started off with just numbers that you knew, 1, 3, 2, 4. Okay, but they said there had to be other numbers besides that. They're like, oh yeah, well, we'll make another one then. We'll say this is called Z, and you can have -1, you can have -2, -3. It's like, great. But then there had to be other numbers besides that. What other numbers did you have? You can have numbers in between those whole numbers. So we went to Q, where you can have half or 3.5 or 3.5 and 1.7, whatever it is, it fits in there. But it doesn't fit here and it doesn't fit there, right? But you can have negative ones of those too. So that's a bigger picture of that. And then they're like, well, what if you can't express it as a fraction of integers? Then that's why the next bracket is they say, fine, let's just call R everything. Everything means anything on the outside is where your irrational numbers fit. So yeah, all the numbers that can't be expressed as a fraction in integers, that's where your irrationals come in. So your surds, root 2, root 3, pi, that's what all comes in. Does that make sense now? All those numbers there too. Yeah? So if you really think it is like primary school, year 7, then you got to year 9 and 10, and then year 11 and 12. Yeah? Okay, that's the sort of process that you're going through. Cool? Now, fortunately for you, the only things you're really gonna probably need to be familiar with are these two. They will use these terminologies, rational, sometimes natural numbers, in their questions, but most of the time you're only using R and Z. So that's a good thing for you. Less things to remember, but I was just giving you a bigger picture. Okay? Now, things to note, R plus, R negative. What is R plus and R negative? Let's go with Matt. Real positive numbers and real negative numbers. What's one thing that you have to be careful of? What about the 0? What did he say? Good, not included. This is one of the things that when you're doing your SACs or your exams, a lot of students will forget this. R plus technically means not including 0 all the way to positive infinity. Whereas R negative is negative infinity up until 0, but you still don't include it. That's the proper notation when you're using in brackets. You don't include it. 0 is not included. If you want to draw a number line to understand it, if I draw a number line, this is 0, then it goes all the way negative infinity up until 0, it's still not included. This is called R negative. Okay? Whereas R positive is all the way here, and that's R positive. Okay? And that's important because when they ask you to define or, to use the domain or to describe the domain or the range, that matters. If you just wrote R plus assuming that includes 0, that's where you lose the mark easily like that. Okay? So that means, well, how do you include 0? If you know it does have a 0, how do you include it? That's where you have to learn the language to use inclusion. And anyone remember how to include again? What's the symbol we use for inclusive? How do we say including? It's like yes, that's for, we call this A. That's for this graph, that's true. So for a number line, you shade it in to show that it's inclusive, which is important when you're graphing. So when you're graphing, open circles means not include, closed circles means that you do include. When you're doing interval notation, the brackets matter. Closed brackets means you include, open brackets means you don't. But then what if you want to do set notations? See the difference? Set notations, interval notations. Union. And that's what I want to teach on this side here. So other common notations, I'm just going to rub this off here so you can see. These are the other set notations that you're going to get used to. Okay, so union is another way of including. So if I want to say that I want all the positive numbers, and any number is fine, rational, irrational, I don't mind. I want all the positive real numbers, but I also want 0, then R plus doesn't cut it. You would have to then say, I want all real numbers, positive, union means include, don't forget to include, and then you got to say 0, but I'm doing something wrong. My set notation's off. Anyone recognize what have I not included? Because you've never seen that. You've seen parts of this. What am I missing? Why is that a problem?
Just brackets.
There's no brackets. What kind of brackets do I use there? Braces. Braces. When do we use braces? Is when you want to identify individual terms. Okay? Why is it a problem if I don't write brackets? What's the problem? Why don't we just write R plus union 0? Why can't we just do that? What issues can you really think of in the long term? It's ambiguous. If I had more terms, what if it wasn't just the 0? What if I had 1, 2, 3, 17, A, B's, and Z's? How am I going to write it? Am I just going to write 0? Maybe I'll put a comma, A, B, C, D. Now, what if I said I want from D to A? What if I wanted to say, yeah, but not only 0, A, but I also want between A to B. So how do I do that? Then you suddenly use all these random symbols there. It doesn't make sense. The symbols we use is that when you wanted to find what are you going to include, you can include an interval. So I could say include from, I don't know, let's say -1 not inclusive to 0 inclusive. I could do that. So that's fine. I'm now talking about a range. So any numbers between -1 and 0, like -0.5, include with the positive side. So if I had to draw down a number line for you to see, I'm saying this. I want everything R plus. I want 0 as well, because I said here, include 0, and in here I actually have 0 included. Over here, I said -1 to 0. So from -1, I don't want to include -1, but I want that all the way to 0. Okay? Obviously, a better notation, instead of writing all that, you should have just said from -1 to infinity, and that would have worked. But you can see this is the same thing as saying -1, and that would have worked. Okay? That would have been a better description, but we call this interval notation. What I'm using here is set notation. See the difference there? Yeah? And then the graph that you're doing here is called, what's it called? Graph notation? No, I don't even know. Number line notation or something like that. Yeah. No, they don't. You can use whichever you want. It's just that they're more likely to use set notation. And what's the problem? You guys were good at this. See, when you guys were answering me, most of you were answering this one and that one. Most of you weren't responding with these terms, and that's why I'm trying to teach you for Year 12. That's the first exercise. The first exercise in 1A is to get you familiar with using set notations, and you have to do that for your SACs and so that you can read it. So when they write it out, when you see this, you should be interpreting that, or you should visualize that. See, this is easy. See, if I gave that to you and I said, does it have -2? You're like, no. But then if I gave you this and I said, does it have -2? You have to be able to read it and say, maybe, maybe not, right? That's the ability. That's what I'm trying to teach you. As the first step, So before you walk out of this class, whether you master it or not, I don't mind. I just need you to be in that mode to go, okay, I need to learn the language. That's 1A. Yeah? 1B is the idea of what function is. You can't understand function unless you understand the language first. Get me? Cool. All right. So you got your union, which means to include. So that's like to inclusive of extra information. What was intersection again? What's intersection? What does intersection mean? Can I please have Bridget? One's in common. Okay, what does it mean when one's in common? Because I hear a lot of students tell me that in year 9 and 10. They're like, oh, it means intersection. I'm like, what's intersection? They're like, in common. I'm like, what does that mean? Like, I have no idea. We say all the same words, we've regurgitated, but if you put it in your own words, what does in common mean? What does in common mean? What are we talking about? What's in common? What's in common? Can I please have, let's go with Oscar. Common values? Overlapping values? Any values that are the same, okay? But how can you have something the same? The only way you can have something the same is you have two things to compare with. You're like, this is the same as this. But if you only have one thing, how can you compare with that? If I just said, this is the same. The same as what? This is the same. That doesn't make sense. Yeah? The only way you can say something is the same is when you have two things to compare with. Or three things, two or more. You're like, these two are the same, or these three are the same, but you can't just say, this is the same. Right? So intersection means that you can't have one line. It means that you have to have two lines because you have two things. So if I want to do an intersection, I can do something like this now. I can say, let's say 1, and I can do, this number will go from -1 all the way to 0, and the other one will go from -0.5 to 1. Okay, so I've got two things now. I've got two things to compare, and now if I asked you where is the intersection, looking at this visually, where's the intersection? Where's the intersection now? Very good. -0.5 to, not 1, because this one doesn't have all the way up to 1.
Oh, 0.
0, good. This is the only two parts that they are in common. If I highlight where they're both in common, this is where, so from here to here and from there to that, that's the only two sections they both have in common. So that's from -0.5 to 0. Okay, and that's intersection. So if I were to call this line A and that's line B, and they say A intersection B, they're really saying where do they overlap? Then you would answer by using set notations or interval notations. Now there are two ways to write that. You can say, I mean there are two ways, but you probably would rather, I would rather write interval notation. But you would say that because that's from -0.5 to 0, and you know this is inclusive and that's inclusive, then you would say it is including from -0.5 to 0. That's one way of describing it. But then you have to say, well, what is this describing? Is it what kind of variable is it? Is it an X variable? Is it a Y variable? Is it a Z variable? I haven't told you what this axis is, so that's why you can't really say what it is. But if I told you this was the Z axis, then that's when you would say Z is, what goes in between? Not equals? Element. Okay? I think you could still write equals. Conventionally, if they ask for a domain, you wouldn't do that. So unless they say Z is the domain, then what does Z equal to? Then you can say that. But because if they say what is the domain, then you would have to state Z is the domain, and it is a part of. That's what element means. So this is the element symbol. Element means a part of. So Z is a part of this range or domain. It is between -0.5 to 0. Does that make sense? Yeah? So you see I'm using the language here. I'm using set notations and interval notations to describe a domain. Okay, because you're going to have to get familiar with reading this, and they're going to use a lot of symbols. Sometimes you might get Z, sometimes you might get Y, sometimes you get both of them in the question, and you have to be able to understand what are they saying. And sometimes they could just be saying this. They could be saying Z, you know, is between -0.5 to 1. It only accepts, I don't know, if I would have put it in an application, I would say something like Z has only accepts, you know, metal sticks between -0.5 centimeters to 1 centimeter. Doesn't actually make sense, but let's just say it does. And you know, Y company only accepts between -1 length to 0 length. You know, and they write it out in this form rather than spelling it out to you. Then you have to be able to interpret that and picture this to answer the question. That's why in year 12 when you do the exams, it's not that the questions are hard, it's just that you had no idea what they were asking. And that's why students get intimidated because they're not used to set notations. Okay? All right, so we had union, intersection, elements. Braces, remember that only uses to identify individual terms. So if I wanted to say not just between an interval, I could have said just include 0 as well. Okay, so that means take all the positive numbers, also take 0. But you could also list a couple of things too. You could have done 0, -1, -half if you wanted to. And that just means take all the positive numbers as well as specifically 0, specifically -1, and specifically -half. Okay, that's what it means. You had a question? Yeah? All right, so that's what braces are. Closed brackets means inclusive, open brackets means excluding. Yeah? Now, after all that, there is one common mistake. Let me just erase all this. This is one that I talked about many years ago, and I don't know if the rule still stays, but just in case, I'm still going to teach you the proper notation for it. Back then, if you didn't do this backslash correctly, you did a / instead, you'd lose a mark for that, okay? Because that doesn't mean excluding. It actually meant something else. I forgot what it meant. But backslash means excluding. I forgot what / means, okay? Backslash means excluding, and I remember that year that the examiners were taking off marks from students who wrote with a backslash, even though everything else was correct. And then the next few years, they said, you know what, we'll abolish it. Too many kids are doing back and forth, but they have the idea correct. And so they put it away. So I don't know when they'll put it back. You don't want to lose a mark for something you know what the correct way should be. Okay, so backslash, not /. Okay, and what does a backslash mean? It just means exclude. So before was include, this means exclude. So what does this mean? It means x, which is the domain or the x-axis. It is a part of any number that you can think of, except 1. So you can think of any number you want, that will be x, except 1. So you can have half, you could have -0.9999999, you can have 0.999999, but you just can't have 1. You can have any number you want, except 1. Okay? And one way to remember that, do a backslash or I'll backslap you. Okay? So you can do a backslash or I'll backslap you. Okay? Just make sure it's backslash. Next one, domain. We all know that that means the x values or the x-axis values. So you have different axes and they have different variables. Then normally, conventionally, x represents the horizontal and the range, which is your y values, are your verticals. Okay, so those who've forgotten those, because you're going to use these for the next exercises in the chapters. But primarily, you're doing these notations there. Okay, so what am I putting emphasis on? Backslash. R plus R negative, because all of you will likely be doing this by the end of this year. I know that you will all use R's. You're going to use R's all the time anyway, because that's the only symbol that you're so good at. And I'll see it in every SAC that even if you're in the worst doubt that you have, you're going to put an R anyway. Even though there's no R, you still put an R. I don't know why they do, but they do, okay? Don't. You've got to think about what you're doing. But I know you're likely to put an R. So you're all going to know this, and we're going to rarely see these. So learn these, okay? R plus R negatives. Learn to use your intersection unions. It's likely you're more likely to use unions more often than intersections. Intersections is normally when you're comparing two things, which means that you have to have two graphs to compare. That's why it's unlikely. Normally you get one graph, you sketch it, domain, range, composite function, whatnot, and you don't do comparison as often. Okay? That's why we don't use intersection as often. But how do we feel with that first page, first line? It's a lot of information, but it's a summary of what you've learned since year 7 and 11. Okay, that's all those notations should be unfamiliar. You would have seen them all. It's now sort of refreshing your memory. Cool. And if any in doubt, you can always watch this again. Yeah? All right, here we go. So now you learned the set notations. Just another language. When I first started teaching in 2012, I didn't know what implied domain is because for me, we don't use that language in university. We just call it domain and range. And so when a student asked me what an implied domain was, I had no idea what they're saying. I'm like, it's a domain that is not spelt to you directly. And funny enough, I was right. It's a domain that is not obvious. So what does that mean? When I give you a domain, I actually tell you what the function is. So if I gave you sketch a linear equation, y equals x, but I only want you to sketch between 0 and 1. See that? I spell it out to you. I tell you that I only want you to sketch between 0 and 1, draw a straight line. Don't draw anywhere else. Between 0 and 1 on the x-axis, draw a straight line for me. Okay? Here is called an implied domain because they don't tell you. But we all know what the domain should be when you do a square root. What can't you square root? Negative numbers. Can you square root of 0?
Yeah.
Yes. Yes, you can. So, on the x-axis, if I had to draw it, this is my x-axis. 0 starts here. Apparently, I can have 0, but I can't have anything over here. So when I sketch it, or my domain, my implied domain is clearly everything onwards. I can square root 4, I can square root 5, I can square root any number over here, I can square root 0 as well, but I can't square root a negative number. So what's my domain? R plus. Very good. So the implied domain here is R plus, which means all positive real numbers, but don't forget, R plus doesn't include 0, union 0. And that's what I mean. In year 12, they're going to do that purposely. But you're not going to get a root x. You'll get graphs like this. You'll get 1 on root x. And students will get the domain wrong there. So you're going to learn that there are parts where you can include and where you can't include. When does that happen? Okay, in this case, actually, you don't include. Yep.
The closed including brackets, when you said like including 0,
Yep.
use those brackets.
No, so when you use union, do you want to include it or not? If you want to include it, use close, and then if you don't, use open. So an example would be, let's say I want x to be, actually normally we use sets, so let's say A union B, but then with B I might want it to, oh this is a bit tricky. Let me use let's do 0 to 1, okay, 0 to 1. If I use the union symbol, okay, it's up to you whether you want to use close or open afterwards. See, from 0 to 1, and let's say I want to include something else. Let's say I want to include between 5 and 6. So then I would say between 5 and 6. But if I didn't want to include 5, then I would use open brackets here, and that's union. So what does this mean? This means I want between 0 and 1, but don't include 0 and don't include 1. And I also want between 5 and 6, include 6, but don't include 5. So if I were to draw that picture for you to see, this is what it looks like. I'm saying between 0 and 1, I want everything between that, but don't include these two endpoints. That's what the first one means. Between 0 and 1, don't include. Union means also consider the next point. I'm doing between 5 and 6. So 5 and 6, so let's say 5 is over here and 6 is over here. I don't want 5, but I do want 6. That's essentially what I'm saying in that interval notation. See, I'm saying I can choose any numbers in between there. So I can have 0.99999, I can have 0.0111111, okay, but I can't have 0. And I can't have any negative numbers. And over here, I can also choose any numbers that is like 5.1, 5.0001. I just can't have 5. Okay? I can have 6. Yeah.
Since they don't overlap, how would you write that?
If they don't overlap.
Yeah, because like the first one, you had 2 lines overlap.
Very good. So if I call this line A or set A, so let's call this set A, and let's call this set B, right? What's overlapping again? What's another word for overlapping? Intersection, right? So I've got A, I've got B, this is intersection. So what am I saying here? I'm saying group A overlap with B. Now this is where what you were saying, where we can define what it equals to. So here I can say, equals to what?
No.
But how do we say none?
No.
No. That just means non-overlapping. So between A and B, they don't overlap. You see what I mean? So you're going to learn different ways, and that might not be the only way to do it. There's so many other ways to describe that they don't overlap. You don't have to use this one. I'm just using what I know, and you're just trying to piece things together to describe what you're trying to say. But you have to describe it correctly, because that's what they're looking for. They're looking for you using the correct notations in what you're trying to describe. Okay, so if out of nowhere, if A was not defined and B was not defined, you using A and B doesn't make sense. Somewhere before that, you had to say A equals to 0 to 1. B equals to 5 to 6, but not inclusive of 5, including 6. Then you can say set A intersection B equals null. Then you can say that. Okay. How do we feel with the language? Sorry? Yeah?
It should be R plus D equals 0.
Say that again? Yep.
When you draw the graph.
Yep.
And the domain for X was R plus D equals 0.
Do we?
Yes.
Yes, we do. So how do we do that?
But you said open bracket.
I said open bracket for this one.
Oh.
Because 1 over root x. Now you can put, if I blocked off the 1, right? Root of 0. What's root of 0? 0. So it's possible to square root, but what's the problem? It's in a fraction. If it wasn't in a fraction, it's fine. But as soon as you have a fraction, why is it an issue? 1 divided by 0 is not 0. 1 divided by 0 is undefined. 0 divided by something is 0. But something divided by 0 is undefined. Okay? I just realized I got caught by this. There you go. So that's why I said this one, on the other hand, is not including 0. Whereas this one would include 0. Yeah. Okay?
For the graph, do we use for 1, 2, 5? Like 1, 2, 3, 4, 5?
Usually you don't have to. But usually you don't do number lines either. Usually if you're actually drawing a graph, then you only label important points and you can estimate. Just don't make it too ridiculous. So if you did 1 and 100 and then suddenly 20 is like here, that doesn't make sense. So there has to be some sort of scaling. Okay. All right, cool. Excellent. So the first exercise is for you to, and I'm going to give you about 5 minutes just to get the feel of using the language. So you've just got all the language, you've got your notes. I want you to answer these 3 examples here. So I want you to, example A, 4. So we're reading it. A, remember A is the set. It's the group. Okay, set is, A, when you say a set, it means a group, a collection of things. Okay, it doesn't have to be numbers. It could have been a collection of chairs, people, tables, whatever it is. It's just that we're doing maths and we've got numbers in there, right? So group A has 1, 2, 3, and 7. And that's it. But notice the notation. Don't take it for granted. Equals. So I'm saying what the set equals to. Braces is what I'm using. I'm defining. I'm not using open brackets or closed brackets. I'm using braces because I'm identifying the individual. I'm listing individual terms, right? I've got 1, 2, 3, 7, and they're separated by commas, and then close braces. Then I did the same thing for B, open braces, and 3, 4, 5, 6, 7, right? So that's my 2 sets. You can visualize it in your head if you want, and then you read the first question. It says A intersection B. And that's how you would have to answer questions. If you were answer question, you can't just write A and B out of nowhere. You have to define like the way they did. You have to show what is A, what is B, then you can use set notations. Otherwise, A and B means nothing. Okay? So A intersection B, A union B. Write down your answers. I'm going to give you 5 minutes. And same thing, exclusion. Okay, backslash, read this. And then same thing over here. I want you to illustrate each one of these on a number line. Okay? Doesn't have to be to scale. We'll just try to roughly draw it. Okay, I'm going to give you 5 minutes. We got 2:24. When it's 2:30, we shall look at the answers. And once you got the notations, we can jump right into what a function is, and that's my second point for today. That's what I want you to learn. What is a function? Practice using the set notations as well. So, for example A, how I would have done it is instead of just doing an equal signs next to it, I would practice to get in the mode of it. I'd do A intersection B is equal to, and then once I know what are the intersections, so I look at the list and I say what is in common. I can see there's a 3, there's a 3, there's a 7, there's a 7. That's where they both overlap or they have something in common. Then I would say 3, 7, but remember to use braces. Okay, so get used to using set notations. Don't just write equals, don't just write 3, 7. Okay?
So you use braces
For listing, very good. Whereas open bracket and closed brackets are for intervals. Intervals meaning that it's a whole list of numbers that you can't list. 3 minutes left. 2 minutes left. All right, let's go through answers. B. Example 1B, what did you get, Stella? What is A union B equal to? Good. 1, 2, 3, 4, 5, 6, 7. What's one thing you have to pay attention here? What's something that my sevens would likely ask? Good. The elements in there my students would normally ask, do we repeat the 3? You guys have now learnt it that you don't, right? Because the 3 is a 3 and it doesn't change. Now, this may be tricky when you're doing probability when you have a word like Matthew. It's a double T. Okay? Why is it in Matthew that you do write down T, whereas in this number system when you write 1, 2, 3, 7 and 3, 4, 5, 6, 7, you don't write the double 3. Anyone know? Good. Because in Matthew, it's a word. We would say the word Matthew or the name Matthew, it has a double T in it, then you stick to that, right? Whereas in the number system, there is only one number 3, and we don't have anything else, right? That's why we use 1, 2, 3. You don't repeat that. Okay, so it's a legitimate question. It's just something that I wanted to point out. When you're doing probability, when you're doing union, you don't include the intersection. Okay? Anyway, so next one. Bit trickier. Example 2, A exclude B is equal to what? Can I please have, let's go with Khadija. 1 and 2. So we're excluding B, and what is, so A, except I don't want anything to do with B, so I don't want a 3, and I don't want a 7. Very good. So it becomes 1, 2. What about if I wrote it the other way? B, excluding A, can I please have, let's go with Aggie. 4, 5, and 6. So let's have a look. So I want B, but I don't want anything to do with A. So A has 1, 2, 3, and 7. I can say again, 3 and 7 is out of the way. So it's just 4, 5, and 6. Okay, so 4, 5, and 6. Correct. Very good. The last ones, I'm just going to quickly draw them out. Just have a look at if you've done the notations correctly. Remember, when you're doing these, it's not about doing it to scale. You don't have to do 0, 1, 2, 3, 4, 5, and write it out. No, you don't. This is an exercise, and it's very unlikely you're going to have to do it in the exam. It's just for you to understand what a number line is and how to use the notation. Okay? So I would have done something like this. Just do a line, 2 arrows to show it goes onwards, and I would have just done -2 to 3. It's inclusive, so close circles. Done. Do the same thing for the next one. -3 to 4. Okay, if you want, you can put a 0 in between it. And then you can say, what's that? Not inclusive, -3 to inclusive of 4. Then for the next one, 5, let's say there's 0. You are including 5, but you want to go all the way to infinity. Draw a line with an arrow. Okay, show them which direction it includes all the way. Okay, and I'll do D, which is exclusive. So -2, 0, 4, non-inclusive, non-inclusive, and there you go. Okay, and the last one's obviously -3, 0, non-inclusive, infinity. Okay, but you can see the way I'm doing it. I did it very quickly, but it describes exactly what you see. You don't have to draw out 0, 1. That's what you did in year 7, but we don't do that now. Okay, when we get there, we're just being efficient in our sort of grammar or direction, what we want. Okay. All right. How do we feel with set notation so far? Feels pretty good? Because 1A is a whole bunch of things to read, and I'll show you this one now. So don't feel intimidated. I'm going to show you this. So you've learned the notations already. This is what I mean. This is a very small example of what I mean by students feeling overwhelmed just by looking at that, right? And you're not meant to, because if you just read it as slowly as you can, it makes a lot of sense. Okay, and then I'll show you the exercises and whatnot. But let's have a look at this one. It says sketch the graph of the relations and state the domain. Let's not sketch the graph right now. Let's just read what is it trying to say. Okay, so what brackets am I using? I'm using braces. So it means listing. What am I listing? What's the bracket x, comma, y bracket mean? Where have we seen that before? Yeah, x, y coordinates. So what did it just mean? It just said, I'm going to list. What am I listing? I'm listing coordinates. What are my coordinates? There's an x variable and a y variable. It doesn't always have to be an x and y. It could have been distance and time. It could have been dt. It could have been yz, whatever you want to call it. It just, conventionally, we do x-axis and y-axis. But you really just take your time. It just means list. What am I listing? Coordinates. My coordinates have an x and a y variable. Colon. What do these coordinates follow? Okay. What kind of pattern does it follow? If it has a pattern at all. Sometimes it doesn't. Like the second one. It has no patterns. So you don't have to use a colon. Okay. So we say coordinates. The coordinates follow the pattern. Y equals x squared. So what kind of graph do I have? Quadratic. So if you were to sketch that, all I'm asking you to do is draw a quadratic. So when you first look at it, it looks intimidating, but if you break it down, you read it, not that scary. Just draw a quadratic graph, y equals x squared, right? Let's read the next one. Now we'll read the next one now. You have in C, brackets means list. What am I listing? -2, -1, that's a coordinate. -1, -1, that's a coordinate. -1 to 1, or not to 1, just 1, that's a coordinate. So technically they've just listed out, plot these points on a Cartesian plane, that's it. Yeah. This one? I haven't even thought too much about it, but that's a good question. Let's visualize that. If you guys can have a Cartesian plane in your head. Let's see, -1 there. Oh, there's 2 -1s, that's true. There's 2 1s. No, there's 3 -1s.
No, I didn't mean that. My question was, is the first one, isn't that dotted triangle, is the x and y? Or is that that's not it?
On this one,
Yeah.
isn't included.
Yeah.
It is included because it doesn't tell you what the restrictions are on x and y. Technically, every graph that you draw is dotted. It's just that because we have infinite domain and infinite dots, that's why it looks connected. But it's not, it's technically infinite dots. So when you do like this, right, the quadratic, it's actually not a line. It's actually made up of infinite dots. And because everywhere in between has a coordinate, that's why it looks like it's filled up. Okay? So it's actually made up of infinite coordinates, and that's essentially what it's saying. It's just saying coordinates, didn't give you a restriction on x, didn't give you a restriction on y, and it just said, follows that pattern. You square x, you get y. So whatever x is, you square it, you get y. And if you do that for every single little r value, so x element of r, any number that you can think of, you square it each time, then you're going to get everything. Because you get everything, you get this kind of line, and we call that the quadratic line, quadratic function. Does that answer your question? Yeah. Okay. So, second one, I'm not sure. Oh, we just established we weren't talking about it. That's just a plot of coordinates. Let's have a look at the second one now, though. So, the second one has a condition. So let's have a look. I'm going to list. What am I listing? I'm listing coordinates. What are my coordinates? I have an x and a y coordinate. What does it follow? It follows the 2x plus 3y equals 6. What kind of a function is that? Linear, it's a straight line. If you rearrange it to y equals mx plus c, that becomes a linear equation. But, so they had a comma, they're putting an extra thing that they want to tell you. What does this mean?
X is larger than or equal to 0.
Good. And x, what is x representing? X is the x coordinate. And the x coordinate traditionally, we call it the x-axis. Hence we say the domain, they just told us the domain is 0 to infinity. Okay, so 0 onwards. So if you were to draw this line, it means that on the x and y axis, whatever this line looks like, 0 to infinity, so this whole region here would have a straight line, but it would not have anything on this side. That's what essentially it is. I just don't know if that's the positive line or not. Is it a positive line? No, it's a negative gradient. So 2x plus 3y equals 6. If you rearrange it, minus 2x on both sides. So you got 6 minus 2x. Divide both sides by 3, because it's 3 times y, so opposite of times 3. Divide 3 on both sides. So you got 6 divided by 3 is 2, and minus 2 divided by 3. And there you go. So now you can read that and you say that's mx plus c. Y-intercept at 2. Negative gradient. Gradient is 2 up, 2 down and 3 across. Okay, so if you were to draw it, it will be like this. When it's 0, it is 2. So when x is 0, y is 2. There we go. There's my graph. Okay, so you just got to put in the important points. Put out the y-axis intercept, draw out the diagram. If you do a straight line, you have to use a ruler. Don't just do that line, because they will look at it, and if any wonky line comes in, they'll take a mark off. So it matters. If you're doing a straight line, do a straight line with a ruler. Okay? If that's been something you practiced in year 11. If you haven't, get in a habit for year 12. Okay? And the scale, obviously you need to label the x-intercept as well, so you solve that. But that's essentially what you're doing. Let's read another one that looks difficult. Which one of the, let's do, this is a good one. What's this one saying? List coordinates that follow y less than or equal to x plus 1. What is it trying to say? Very good. So if we were to visualize this now, what kind of coordinates do we have? Okay, we're listing a coordinate that follows a function, right? And what is the function? We have y is technically equal to or less than x plus 1. So the question, what does x plus 1 look like? What is x plus 1? Y equals x plus 1. What kind of graph do I have? Linear. So if I draw x plus 1, y-intercept is at 1, and x-intercept is at -1. So this is what my graph looks like, right? That's all the equals. This is when y equals to x plus 1, right? This is the graph of y equals x plus 1. But I also want y is less than x plus 1. So what would that be? Where is y less than x plus 1? Fourth quadrant, good. Anything below the line. This is your standard. This is when it's equal to. That's when y equals to the line. This is when y is above the line. This is when y is below the line. So all the coordinates that are below that is what I want. This is essentially what you want. That's what it's saying. You see that? Every coordinate in this region here. So if I, instead of doing those dashes line and it might confuse you, I'm just saying I want all of that. Because every coordinate there describes, every coordinate that I just chose satisfies that. Because whatever x plus 1 is, see x, let's say when x is 2, 2 plus 1 is 3. Yeah? That's where it is. If I chose a number here, it's going to be less than 3. True? If I chose a number for y, anywhere number here is going to be less than 3. I can't choose a number greater than that. See what I mean? For x equals to 2. Yeah, when x equals 2, I just want to choose a y value that is less than that. So all these coordinates here fit that. So just to really consolidate what I just said, when I say x is 2, at this point, according to the rule, x is 2, then y is 3, according to the rule, x plus 1. True? Then all I'm saying is, if I want y to be less than this fact, then I can have 2, 2. Agreed? 2, 2 fits the genre, because the y value is less than x plus 1. True? It's less, and it just keeps going. I've got all this, so that's why this whole entire region fits that description. If I switched it around, if I said greater than, then it's all these regions. And also greater than and equal to. What do you think would happen if I said this? What if I changed the problem and I asked you to sketch y is greater than x plus 1 only? So this is my x plus 1. This is 1, -1. And I know it's all these regions here, but I said I didn't want to include. I want to be greater than, but not equal to. So how do you show that? Dotted line. Like what? You want a dotted line here. Because you're saying you don't want to include that line, because that line, that's when it's equal to. So you have that. That's your dotted line, not inclusive of x plus 1, but you want all the y values that are greater than that. These are all the y values that are bigger than that. Okay? So that would be something a bit challenging from last year, that you would have remembered discriminants, working out inequalities that are above and below or in between. This is essentially sort of tying that in. But what I wanted you to take out from this session was to feel less uncomfortable seeing these things. Okay? Every time you see something in the exam that looks like this, or the SACs that look like this, I want you to take your time. Read it. Don't just go, oh my God, and then flip to the next page and say, no, I can't do it. You can. Because a lot of times it looks hard, but it's easier than you think. You just sit there and read it. Read it, break it apart, see what it's really trying to say, and you'll find it's so easy to do. Okay? But that's what essentially this is all is. Okay, that's all it's trying to say. All right, this one's talking about domain and range and getting you to use these set notations. All right, how are we going? We've got a nice half an hour. How do we feel so far? So the first part of the session, set notations. Have I made you feel somewhat more comfortable with reading the language? Yes? Cool. All right. Just before we get into what is a function, because that's the second half, and the next half is going to be where I need you to go back home and really think about it, because it's the bread and butter to the next few functions. And everything that I showed you before, 1 on root x, you won't understand that unless you understand what a function is. Okay? I'm going to give you a nice 3-minute break. You can stand up and probably stretch or whatnot. We'll get a 3-minute break. You can chat a bit or so, and then we'll get back onto this. I'm going to stop the video as well, so it doesn't go too long.